And this is a little bit of an experiment because this is the early start of a new kind of robots. So with me today I have sort of a vision of how we can combine plants and robots, and we are starting to speculate why would that make sense, how does that influence things. So this is a talk about an EU project, Flora-robotica, that has been running for only 4 months. So it's basically, we're trying to conceptualize, coming up with visions, coming up with sort of engineering goals to reach and so on. So it's really an active process, and you get a little glimpse into where we are 4 months into this. And also, interestingly enough, it has a strong influence from the arts, in particular architecture, so it's not so engineering focused as some of the other things you will see. So overall, our goal, the engineering goal or the architectural goal, is that we want to integrate plants into ordinary architectural practice. So we have these kind of streets in Spain where you have your architecture, you have the buildings around, and then some clever people manage to plant these beautiful plants, and they serve an architectural function here in shading this street. And I think we can all sort of agree that this street is much more pleasant from a human perspective than a plastic roof or a glass roof or anything artificial. So here's a case where clearly the plants are serving an architectural function in concert with the man-made structures. But architects, they don't put plants into their designs normally, but something that's added after. And we want to develop technologies and ideas that allows them to early on conceive that plants will be part of the architectural structure already from the beginning and serve some architectural functions outside of just looking nice. So from an engineering point of view, and I am an engineer, it's also interesting to look at plants as machines that can produce material. So if you look at the way we do construction today, it's very expensive. There's a lot of materials involved, there's labor cost, there's transportation of all this material, really high energy consumption. Cranes takes a lot of power, all the machines takes a lot of power. It's always predetermined, so once the building engineer has his drawings, we know how the building will look like. At some point in time we want to get rid of the building, but it's not biodegradable, so the buildings stand around for a long time and create tourist attractions, which I guess is good, but normally we want to be able to recycle or decompose these used buildings. And then the aesthetics come through design, so the architects get famous for their beautiful designs. And even when the building is there, it's really high maintenance. So there's a lot of the windows have to be cleaned, it has to be maintained, the concrete is crumbling and so on. So even though we're doing it this way, you can very easily criticize conventional construction, and it's not really something that goes aligned with green energy and a better future. Whereas if you look at plants, they magically seem to do this very, very differently. So the way they grow is essentially free. So of course it's not free, they have nutrients in the ground and there's still solar light coming in, but they basically grow without much human influence. So it's very cheap compared to the way the buildings are built. Also, there's no energy consumption, not anything we have put in. The sun puts everything into the system that's needed to keep these plants growing. And they are also adaptable, so once they start growing, if they meet an obstacle, they can grow around it, they can adapt to the environment in which they're planted. So the architectural structure, if it was based on plants, could adapt to where the structure is going to be. Clearly they are biodegradable, they are plants. And also, I think they have sort of this inherently aesthetic quality, and I think it comes from sort of our biological background that we appreciate being around plants and these kind of organisms. And then finally, they are actually also self-repairing and renewing, so if they're damaged, they just continue to grow and seal up themselves. So they're sort of a perfect creature to use for building maybe not this kind of structures, but smaller architectural structures. Okay. So they're not completely perfect, so they have some some limitations. For instance, they can only do certain things. So we are not going to build a waterproof wall out of plants. I mean, it has to be a hedge. It will be semi-transparent. The other thing is that they grow really slow, so we have to wait 50 years for our building or bus stop to come together if we're doing it only with plants. And they also have to be sort of maintained in homeostasis, which means that they need water, they need to be treated so they actually continue to grow and don't die. And the last thing is, of course, that plants are uncontrolled, so they don't naturally grow into bus stops or buildings or something like that. And this is, of course, why we are doing it this way today. We can build whatever we want. We have many materials available. We can do it super fast. And the maintenance cycles are, well, let's say pros here. And the maintenance cycles, even though they're there, they're quite long, so we don't have to maintain very often. And finally, this is controlled. So I'm not a magician, so I can't really do anything about functionally limited and slow. But the things we can maybe do with robots is that we can help the plants to grow, and we can control them so that they would grow into the shapes we actually want. And that's where robots come in this talk. And this is not completely outrageous. There's actually several examples now in the world of people who have formed plants for particular purposes. So here is Peter Hook's hook tree chair, where you basically have the tree that's growing, and then as it grows, he's changing the shape time in certain ways, so it's grown into a structure that serves a nice purpose. So here it's a chair. There's a startup in the UK called Full-Grown. That are growing chairs, so they have the plant coming from below, and it's sort of embedded in this plastic box that makes sure the plant grows is constrained in some way. And then actually after 5 years of growing, they cut off the plant, take off the scaffold, cut off some branches, and then polish the chair, and they have a chair grown directly for this particular purpose. So that's kind of impressive. And of course they also have to struggle, so it takes no 5 years to get your chair out of the system, but then once you have it, it's structurally very strong because there's no joints, there's nothing, so presumably it can last for a very long time. And there are more examples, and I think this is one of my favorites. So this is the living root bridges of northeast India. And here the idea is that you have these mangrove trees growing, and they have these long roots. And people have, for many years, every time they pass the bridge, they sort of weave the roots a little further. And they've been doing this for almost 500 years, and these bridges are sort of self-sustaining in that they grow more and they weave more. Of course they get worn, but then there's more growth. So they actually have been stable for 500 years and serve sort of an important function for the local society. So I think there's some examples that actually plants can be useful if we're willing to wait a little bit for them to grow. And then the problem here, from an engineering point of view, is that if you're going to build a bridge, it's nice with these villagers who are sort of have their own interest in doing it. But if we have something different, like the chair, we need people who can cut the branches, we need people who can shape it, so it's very labor intensive to turn trees into what we want them to be. So bonsai is something that requires time and patience and a lot of labor. Also it stretches over a long period of time, so you have to cut the tree every day for 5 years, which is not very nice from a human perspective. And then finally that means that it's not cost competitive, so it's really hard to make these nice wooden furniture because the cost of them is simply too high for the average customer. So these chairs, I think they're now 5,000 euros for a chair because that's the amount of money that went into the industry. And I think these are good challenges for robotics, so we can basically automate this process and try to make the structures grow into what we will and use the robot as sort of a gardening robot trying to maintain the plants on the path where we want it to go. But then I should say, before we get too carried away with the application, we're doing basic science, so we're also just trying to understand how plants work and how we can interface robots to plants and what kind of futures that can create. So this is an artistic rendering by Andrew Lincoln Nilsson about these sort of plant-robot hybrids and how they could look in the far future. So we are not specifically tied into this architectural goal. We're also trying to understand some of the fundamental scientific challenges of having plants and robots interacting. So just quickly, if we talk about the robot partner, the robot symbiont in this system, it should somehow complement the plant. So the plant has some very nice features I talked about before, and we should make sure that the robot doesn't ruin all that. It would be sad if the robot was super expensive, given that then this advantage of the plant would go away. And you can simply see all the other characteristics that we want out of our plant systems. And as a researcher, there's an interesting opportunity here in plant robotics, because for once we have something called slow motion robotics. So slowly the robot can wake up once a day, check sensors and then do something, and then wait another day before it does something again. And that opens some new interesting opportunities, because the robot will be able to harvest energy from solar panels, from something like that allows it to power itself, so it won't need any external power. And that's simply because we're talking about slow motion robotics when we're talking about plants and robots. So this is sort of where we are, so that's the motivation and where we are going. And the current concept we are developing and are starting to implement is a system that looks something like this. So you would have your green plants. We have beans and wines and strangler figs are sort of our typical plants. And we grow many of them, and we look at them as a swarm of material producing entities. And then we can create this scaffold, which is the mechanical part, which helps the plants can thrive on to this scaffold, and given that the scaffold is shaped in certain ways, that would control the shape of the resulting plant in some sense. And then we have these robotic or electronics group we talk about, that are basically electronic modules that are powered by solar panels that are able to maybe shine lights on the plants to control the direction of growth, or able to sense where they are in order to control the process. So this is sort of the overall design concept. You also have the human here, and the idea would of course be that even though we have built in a plan for what we want the plant to be, the human should be free to interact with the structure such that he can enforce that, here the plant will grow further in this direction, and he can create the plant structure, plant robot structure that he wants to. So let me just talk briefly the last few slides about what are we trying to look at. So one of the key challenges we have is robot-plant interaction. So we're trying to figure out how the robot can sense the plant. Yeah. So simple technologies here is that we can use infrared light, proximity sensing, we can measure biomass like the weight and the strain on joints to figure out where the plant is going. And we can measure electroactivity, so actually there's electricity traveling up and down the stem of the plant, and we can measure this, and we can also measure water transport in the stem of the plant by having a little ring going around the stem. We actually know how much water is going up and down the stem. So those are the kind of things we can use to understand what is going on inside the plant, but they're not developed very highly, so that's some of the things we'll be looking at, trying to figure out how the plant is feeling and what the plant is doing. The other thing is this challenge of making them go where we want them to go. And the most powerful thing we have at the moment is this mechanical guidance. We know that works. Put them in some scaffold that guides them in a certain direction. And we can build this scaffold or lattice in a way that it can deform, so we can change the shape of this overall structure over time to guide the plant. We can do shading, so we want to shade certain parts of the structure to repress plant growth in those areas, whereas in the other areas where then the sunlight have access, the plants would grow more strongly. We can also shield them from stress, so plants are very sensitive to mechanical stress, so if you basically touch plants just once a day, they grow 50% slower. So it's really, really sensitive to stress, so we can have vibrating motors inside our mechanical structure that will stress the plants and repress their growth again in regions where we want it. And then of course we can control watering. They also don't grow very happily if we restrain the water and the nutrient flow in the system. Maybe one last thing, and we're also very interested in, is that plants actually are surprisingly sensitive to their environment. They are not just dead machines in some sense. So actually we've already done many experiments where when there's a human entering the room, the plant reacts and generates an electrical signal that we can measure. So basically we can use the plant as some form of sensor, and they're very sensitive, and it's due to the changes in CO2 level or the changes in temperature that happens when a human moves into the room. And this is what the plant can pick up, and we can use that to learn about the environment. So we're very interested in this, which is called phytosensing, where you can use the plant as a sensor. Alright. So I'll just finish and say, so with the concept we have come up with, we are really talking about a cheap robot platform because it's basically a dead mechanical structure, and we only apply these electronic fruits where we need specific guidance, and of course the fruits can be reused and take them off once you're happy with the structure. We have low energy consumption because we only have to be active very infrequently, and we can harvest all the energy needed to run this particular robot. The robot can also be adaptive, so it's made of this scaffold where the human can attach new pieces, so it can grow similar to the plant, but sort of in a human meditative way. And then finally, the rods, we can make them very easily of biodegradable material, so the structure may decay over time and the plant may take over the function. So you can imagine we'll build the structure fast, and that takes the form of a bus stop, what with shelter. And then as the plant grows, the mechanical structure decomposes and leaves us with the plant in the long term. So those type of things we can also do, and then we just need somebody to come and collect the electronic fruit and move them to the next place. Good, and it also have these others, so the aesthetic quality we think are maintained. We're not having some weird robot arm standing there. We have something that sort of aesthetically integrate well with plants. The robots are easily replaceable, so if part of the mechanical structure is damaged, we can just add new mechanical pieces and continue growing the artificial plant or the artificial structure. And of course the robot can also provide some of the functionalities that the plant cannot. Still, it's slow, but now we can control it. Good, that was the end of my talk, so I hope I've given you sort of a vision of how you can use those robot plant system, and it's sensible to some degree to try to understand if we can use them for architectural purposes. And I've described some of these concepts we're trying to explore in order to make this happen. And we are currently sort of researching these phytosensing applications, trying to understand how we can use the plant as a sensor, how the robot and the plant can actually interact with each other, and how the robot plant can interact with humans that are in the environment around.